Okay, so we are now going to start recording the math problems on the semester study guide. We had a little conversation in the last hour that we had about what would happen if I just skipped all the math questions, I just didn't even try them, because what I had told them is the math questions that are on the test are going to be similar in nature. So like you're going to have the same kinds of problems, but the numbers are going to be different, right? So, and I'll give you some examples as we go here, but you are going to have different numbers. So if you decided not to do the math problems, and by the way, these are all the math problems on the study guide. There are 8 of them. If you decided not to do the math problems, like the best score that you're going to get on the semester test is going to be about an 86%. So these are going to be worth about 14 points out of the 57. So it would be, or not 14 points, it would be 14 percentage points off. So it'd be about an 86. So just keep that in mind. I don't know, like if you're aiming for an A on this semester test, you might want to try 1 or 2 of these math problems. So here we go. We're going to start with number 26. You do need to know the formulas, so that's why we're writing these down today. I am not going to provide formulas for you, so you will need to write these down. So number 26, okay, the formula for number 26, I think we may have gone over this in the last video, which I worked it out. This is the one about galaxies. The distance is in light years. The recessional velocity is what they're looking for. This is the original formula right here, where Hubble's constant is 2.30 times 10 to the negative 5th. But they're asking you to calculate velocity. So what we did last hour is I had them rearrange the formula for just to solve for v, which the formula looks like this. V is equal to distance times Hubble's constant, which means that you're going to put your distance in there as 25,000 times 2.30 times 10 to the negative 5th. And if you plug this in your calculator, you got to make sure you're doing it correctly. 25,000 times, I'm going to put parentheses around that second number, Hubble's constant, 2.30 times 10 to the negative 5th. And you end up with about 0.575, okay, which is letter C. Now remember, I'm probably not going to ask you about 25,000 light years, may not even ask about this galaxy, but it will be a galaxy that is a certain number of light years away, and you've got to be able to set up this problem and solve to find velocity, okay? Let's go ahead and look at number 31. So 31, it says if a radio wave has a frequency of 105.7 megahertz, and if you'll remember, frequency is this little symbol right here. It's a little fancy V. And it travels at the speed of light. And remember, speed of light is represented with a C, a constant C. It says find its wavelength. Wavelength is that weird looking upside down Y. So the formula that we use for this is going to be the speed of light formula. C is equal to V times wavelength. Frequency times wavelength. And remember, it's an inverse relationship. So if one goes up, the other has to come down. Or if one is a great big number, it probably means the other one's going to be really small. In order to maintain a constant speed of light, which they give you, I'm going to go ahead and put in what I know. It's 3.8 meters per second. And I'm going to set that equal to, I'm looking for wavelength, find its wavelength. So I don't know the wavelength, so I'm going to go ahead and just write that down. I'm looking for that, times frequency. Now here's the thing. They give you 2 different values here, so how do you know which one to use? This one has a unit out here in front of it, megahertz, so million hertz. This one does not. And if you think back to what we talked about earlier in the semester, hertz simply means cycle per second, or like 1 per S. You're going to want to use this value because you don't want to use like mega cycles per second, or you don't want to use that prefix. You're going to want to use this value. So I'm going to go ahead and plug in 1.057 times 10 to the 8th cycles per second. How would you get this wavelength all by itself? Well, since these two are multiplied, you just do the reverse, right? We're going to divide both sides by 1.057 times 10 to the 8th. Oops, forgot my 7. Yikes. All right. So in my calculator, I'm going to type in, and I'm going to use parentheses, 3.00 times 10 to the 8th divided by parentheses 1.057 times 10 to the 8th. And I end up with 2.83822. So if I look over here, the closest thing is 2.84, and then I'm going to look at the unit and make sure it agrees. 2.84 meters. Since they were asking for length, that would totally work. So 2.84 meters is your best choice there. Like I said, same kind of setup, different numbers, okay? All right. Looking at the next one, number 36. Okay. X-rays are used to take pictures of bones, teeth, and other tissues. They can have wavelengths as short as that. So this is our wavelength. Calculate the energy associated with X-rays. Okay. If you think back, we had a couple of formulas for energy. We had this one, energy is equal to H times V, where H is Planck's constant, which is 6.63 times 10 to the negative 34th joules seconds. And V is frequency, which is measured in cycles per second. But the problem is they don't give us frequency here, do they? They give us wavelength. So instead of using this formula, we're going to have to use a variation of it. So we're going to say E is equal to H, Planck's constant, times, instead of saying frequency, let's just sub in the speed of light over wavelength. We'll use that formula. Okay? So now that we know that, let's go ahead and see if we can solve for energy. E is equal to 6.63 times 10 to the negative 34th joules seconds times the speed of light in a vacuum, which is 3.0 times 10 to the 8th meters per second, divided by wavelength. Oh, wait, sorry. We have that value. 1 times 10 to the negative 9. Okay? So there's all of the stuff that we know. So now what we're going to do is just multiply and divide. I'm going to go ahead and do this operation and then times it by Planck's constant. So in my calculator, I'm going to do parentheses 3.0 times 10 to the 8th divided by my wavelength, which was 1 times 10 to the negative 9th. And then I'm going to take that and I'm going to multiply it by Planck's constant. And I end up with, if you can see that, 1.99 times 10 to the negative 16. Okay, so let's look over here. The one that's closest to this is this one. That looks pretty, right? So let's check the unit. They end it with joules. Joules is energy, right? So that would totally work. So let's see. Going pretty good so far? Yeah. Okay. 41. Here's a problem that the math is not hard. It's just, it's going to be a big problem because we've got a lot of information. This goes back to the unit where we were talking about heat and changes in heat. So if something gets dropped into a cold water bath,
please come to the office.
One thing will lose heat while the other thing gains heat. So the first thing I'm going to do is just sort out my information. I know that I'm dealing with a sample of unknown solid that's heated to this temperature and is placed into a calorimeter containing this much water at this temperature. Now the final temperature of the whole system is this, and it says what's the specific heat of the solid. So I'm going to make myself a little table, and I'm going to put, this is my solid, And this is going to be the water that I drop it into. Okay, the mass of the solid that they tell me was 28.6 grams. The mass of the water was 85 grams. Okay, the next thing that they tell me is that it's heated to 62.5, which means that they probably just had it in an oven or like on a flame and got it up. The first temperature, the initial temperature of the metal was like 62.5 degrees Celsius. And it was placed into a calorimeter containing 85 grams of water at 23.3 degrees Celsius. So that water started out at 23.3. Now, the final temperature of the whole system was 26.2. So my final temperature for both sides is going to be 26.2. And final temperature is 26.2. Okay. And then it says, what's the specific heat of the solid? So we're looking for the specific heat of the solid. One thing I didn't write on here, which I probably should have, and I'll try to remember to do this on the test, is the specific heat of water is 4.184 joules per grams degrees Celsius. Okay. So if you remember back, we have this formula that looked like this. Q is equal to MCAT. Looks like that. Does that look familiar? Okay. And we said that if heat is gained by one system, that means it has to be lost by another system. So then you've just got to figure out which side is which. The metal starts out at this temperature, then it goes to a lower temperature. So you could say, oh, hey, or yeah, one, can you get that? The solid is actually going to be losing heat, right? So this one is going to be losing heat. The water is going to be gaining heat because it goes up in temperature. So this is going to be a positive Q. This is going to be a negative Q. Okay. So here we go. And I didn't even look at that. Can we see that okay? It's kind of dark. All right. So what we're going to do here, so since this is our negative Q, I'm going to say negative 28.6. There's my mass times my, I'm going to go ahead and do my final minus initial. So I'm going to do 26.2 minus 62.5. So I've got negative 36.3 times my specific heat, just like that. Okay. And I'm going to set that equal to this side. I'm going to set it equal to my positive Q. This is my water side, so I've got that much water. And then I'm going to do 26.2 minus 23.3, and that ends up being 2.9. That's the amount of heat that was gained by the system. And then the specific heat is 4.184. Okay, so there we go. All right, now at this point, it just becomes an algebra problem. We're just going to multiply a whole bunch of junk together and divide. So I'm going to start with this side. I'm going to do 85 times 2.9 times 4.184. And I end up with 1,031.4 is equal to, and over here, I'm going to do 28.6 times negative 36.3 times a negative 1, right? Which basically is just going to make it positive. Yes? Okay. So 1038.18x. All right. So at this point, what do you do now? Well, you got to get this x all by itself because we want to isolate it. So we're going to divide both sides by 1038. So I'm going to do 1031.4 divided by 1038.18. And end up with 0.99. X is equal to 0.993. I'm just going to use 3 significant digits here. It gives you a whole bunch, but I'm just going to round it off to 3. So what should this be? So if it's specific heat, you got to remember specific heat is the amount of energy needed to raise the temperature of 1 gram. Wait, let's see, joules per, yeah, grams degrees Celsius for 1 degree Celsius. So there you go. Oh, and you got to find the best answer. I forgot this was multiple choice. Anyways, that one right there. Okay. All right. But there will be a question similar to that in nature, and you just got to pick the best one. So that's a big one. Okay. Next, so that was number 41. Number 50. Okay, number 50. This one is an equation writing. I don't know that I'm going to have you guys balance equations. I may just have you like pick out the right coefficient or something like that, because it's a pain in the butt to have to type that out. So, but aluminum oxide is formed. If it's saying it's formed, would it go on the left or the right of the arrow? To the right. Very good. So aluminum oxide is formed when aluminum combines with oxygen. Okay, so there's our equation. Now we want to make sure we write the balanced equation. So letter A. So if we balance this thing out, I'm going to not mess with aluminum because I know I'm going to have to go back and change that. Oxygen is messed up. So you have a 2 here and a 3 here. So our common factor, denominator, I don't know. What would they both go into? 6, right? So 3 here, 2 here. Balance it with coefficients, right? Okay, and then now we've got 4, so that's going to be a 4 there. So there's our balanced chemical equation. It says how many grams of Al2O3 are formed. So I'm looking for this. All right, are formed when 23.6 grams of this. So I've got 23.6 grams of this. This is that equation where you can do it a couple different ways, but basically you could set up a mass-to-mass direct proportion if you wanted to. You could take the known amount over X number of grams, so 23.6 grams over X grams of this. So this is my aluminum. This is Al2O3. And I'm going to set it equal to, what do I know in the problem already? Well, I've got 4 of these, so 4 times the molar mass of aluminum. And I'm going to use my cheat sheet here because I've already done this problem once. So if I took 4 times 27, which is the molar mass of that, it's going to give me about 108 grams. And if I did 2 times this mass right here, that's going to give me about 156 grams of that aluminum O3. Okay. And then at this point, you're just going to cross multiply and solve for X. X should be 34.1 grams of aluminum oxide that get produced. Okay, that's how you would do that. I think the bell's about to ring, so if I get cut off here in a minute, just I'll finish this. Or actually, no, we got 10 more minutes, right? Is it 1:55? Okay, yeah, never mind. Oh, we got plenty of time. Good. Okay. So, but there you go. That's how you do that one. It's a mass-to-mass stoichiometry problem. I got 34.1. Why, what'd you get?
So would it be 108x divided by?
Yeah, what'd you get when you did like 23.6 times 156?
3,681.6.
Yes. And then you did 3,681.6 divided by 108? Yeah. Yep. Yeah, it should be around 34.1-ish. Yeah. All right. Good. Any questions on that? Good. Hopefully it's bringing back a real fuzzy memory, I hope. Okay. So now, these are the problems. Now listen, if you're only going to elect to do a couple of math problems on this test, these are the ones I would do because they're real quick, easy ways to earn points. These are just, this one is going to be a mole-to-mole problem, and there will be one of those on the test, and those are real simple to do. This is just going to be a conversion problem. So let's look at this one first. They say ethane reacts with oxygen. So there's our reactant. So I'm going to go ahead and write down my C2H6 plus oxygen. And then reacts to form water and carbon dioxide, just like that. Okay. So if I know that, it says how many moles of CO2 are produced. Oh, wait, before we even get to the question, let's go ahead and balance this sucker. Because we always do that, right? I'm going to put a 2 right there, so that takes care of my carbons. I'm going to put a 3 here. That takes care of my hydrogens, 6 and 6. Now, on this side, how many oxygens do you guys see on that side? 3, 7, right? Yeah, you got 7. Well, that sucks because that's there's no way to get this to be an even number. One thing that we talked about, though, well, what would 7 divided by 2 be? It'd be like 3.5. Now, because of the fact that we're in a hurry, we're going to leave it like that for now. We're going to leave that half in there because we're not really going to need it later anyway, because they're asking us for ethane. They want to know how many moles of CO2 get produced from 5 moles of ethane. So you're really just looking at the relationship between those two things. So let's look at the mole relationship. So let's look at the coefficients of our known to our unknown. What is the mole relationship of this one to this one? 1 to 2, right? It doubles. So 5 moles of this, if you had 5 moles of this, how much are you going to produce of this? 10. Yeah, so it'd be 10 moles. So mole-to-mole problems are super easy. Just got to make sure the equation's balanced, but you don't have to do any hard math there. 52, what's the mass? So we're going to be looking for mass in grams of 4.33 moles of copper. So if I've got 4.33 moles of copper, and I'm trying to convert this to mass in grams, I need to know how much does 1 mole of copper weigh? Yeah, and if you look that up on the periodic table, the molar mass of copper, yeah, it's that, 63.546. I'm going to just cut it off after that first decimal place. So I'm going to do 63.546 grams. All right, and then just multiply. Yeah, moles to grams, you multiply. Moles to grams, you multiply, right? If you have to go backwards, grams to moles, you divide. But I'm just going to multiply 4.33 times 63.5. And when you do that, you should end up with, I think, 275. You plug it in. So that times that. On Monday or Tuesday, you'll have a similar question, but it's going to be a different element. Okay? All right. So there you go. Moles to grams, you multiply. And then one more, I think. 56. Yeah, last one. So 56, here's the reaction. How many grams of sulfuric acid can be produced from 38 grams of sulfur trioxide in excess water? Okay. So I'm just going to label this. I'm going to leave it in there because I don't have to balance this. If you look at it, it's already balanced. You always need to check that, though. So how many grams of sulfuric acid, which is this one, could be produced from 38 grams of sulfur trioxide, which is this one. So I've got 38 grams of that. I don't know what that is, but I know I want it in grams. So this is another stoichiometry problem. It's going to be another mass to mass. So I'm just going to set it up. I'm going to set up my known over my unknown. 38 grams over X grams. That. So 3. Set it equal to, and I'm going to go back and look at the original equation. So sulfur trioxide, if you do the math there, it ends up being like 80 grams. Sulfur plus 3 oxygens is about 80. And if you figure this out, if you look it up on the periodic table, that ends up being around 98. Okay, and then we're going to cross multiply. solve to find x. So 80x is equal to, I don't remember what I wrote down. Okay, 38 times 98. 38 times 98. 3724. Okay, how would we solve for x? Divide, right? Divide both sides by 80. Divide by 80. You end up with 46.55. So I'm going to do 46.6 grams of H2SO4. If I look over here, there it is. Okay, that's it. Remember, the numbers will be different. Oops, sorry. The numbers will be different, but same kind of setup. So as long as you have the formulas written down. All right, that's it. Good luck.